Hey there, geometry students. Welcome to the lesson for 5.2. Can be found on these pages here. And here's your new vocabulary. And a quick reminder again to use those extra examples in your book for additional help with your assignment, with your classwork or homework. So let's get started here. 5.2 though. Before we get started with some things, I need to show you some stuff here. So if you don't have this right now, you need to go get one of these. Compass. So we need to do this to draw circles with. You need to go get a compass if you do not have a compass. Pause the video if necessary. You also need a protractor. So you got to measure some angles with this. This needs to be done and drawn nicely, neatly, correctly for this to work, for you to get full credit. And you need a ruler, so something to measure things with, something we can find the midpoint. Something with. Go get those things. If you do not have those things, you need those. Pause the video, go get them, and come back. Alright, so at this point we should have those items here. I've got the built-in compass, protractor, and ruler right in here. So I'm going to be using those to show you how it's done here. So we are starting with bisectors of a triangle in this lesson. We're going to talk about perpendicular bisectors and angle bisectors. We've done both of those things before, but not in the context of a triangle. So now we're going to do those things within the context of drawing triangles. Alright, so I'm going to start off with this here. This is your triangle. I want you to try to draw this a little bit thicker than the rest of this. So let's go with, and you're going to draw an acute triangle. Try to make your triangle look like mine as much as possible. So an acute triangle. I'm going to have this bottom part be relatively flat, parallel with the blue lines on your paper. I want an acute triangle, so I want to make sure that this angle up here is going to be less than 90. For that to happen, I would say this would be good. So right about there. And then that's going to be a little less than 90. So now I have my acute triangle, and I want you to leave, if you drew it like mine, you should have plenty of space to fit everything in here underneath. You're going to leave a little bit more space under here than up here. So we don't need as much space up here as we'll need down here the way I've drawn this, but leave about 3 lines down here, at least 3 lines of blue space from here to where we start writing down the steps. So let's get started on this, and let's start writing down the steps for these things. So just draw the triangle first. That's what we had done first. This is step 1. Step 1 is to draw any triangle you want. Call it triangle A, B, C. So I'm going to call this point right here A, I'm going to call this point up here B, and this point I'm going to call C. Alright, step 2. The first one we're drawing here is with perpendicular bisectors. The next one we'll draw will be with angle bisectors. But perpendicular bisectors cut the segments in half, cut the segments of the triangle in half. So we're going to need to find the midpoints of these sides, of all the sides of the triangles. So let's do that next. So find the midpoints of each side. We need to be very precise when we're doing this in this lesson. So we have to draw this nicely, we have to draw this neatly and precisely. So let's get out our ruler. I've got my ruler right here. You can use either millimeters, centimeters, you can use that side, or you can use the inches side. I'm going to go with, there we go, I'm going to go with my millimeters, I think, or my centimeters. That's a little easier to think of. So each 10 is actually 1 centimeter on here. Right now this is listed in millimeters. So I'm going to be saying things in terms of millimeters. If I take this and line it up nicely, that looks to me like it's going from 0 to right about 74 right there. So what is half of 74? That is going to be 37. So at 37 millimeters, I'm going to draw a little point right here. So I'm going to draw that in right there. I don't think I can do that like that. Let's see. Okay, so my ruler seems to be wanting to lock into place right up against this line, which is kind of a good thing, but only if I want it right there. So 37, I move this down a little bit so that it lined up with that. So yours is going to be different most likely than mine. You're going to have to measure yours and find exactly halfway in between. So if yours was 50, you'd put a mark at 25. If yours was, if you measured with inches and you got 1.5 inches, you'd have 3/4 of an inch, something like that. Just find halfway, make sure it's exactly halfway. So we're going to do the same thing with my other sides as well. So I need to line this up so that it's parallel to that first of all, and then I'll put it right on 0, pull it back a little bit. Still got to rotate mine just a little bit more. Okay, that looks pretty good to me. This is going from 0 to, if I put it right up against it, and I'll move it back afterwards, that looks like about 59 to me right there. If I move that this way, I think that's a little better. So 59, 60, I would say. So 60, we're going to find halfway of that. That would be 30. So I'm drawing the midpoint in there. Let's keep that good to go there. Oh, come on. There we go. Just had to move it a little farther back on mine and do the same thing over here. So I'll just move that and show you after I'm done. Okay, so I got it lined up. It looks like 66 to me, so I'm going to back that up just a little bit and go halfway at 66 would be 33. So right about there at 33. Okay, so I got my point here, here, and here. These are the exact midpoints right here, and right here. I measured them and found exactly halfway in between. So I'll put my ruler off to the side, and now what I want to do, step 3 at this point. Step 3 is to lightly draw, and I want to emphasize lightly here. Notice this was a bit thicker, what I drew in here. So lightly draw lines at 90 degrees through each midpoint. And then this has got kind of a fancy name called the point of concurrency, spelled like that, concurrency. So it's like currency, money with a con in front of it, concurrency. We're going to call that point P. So I'm going to move my ruler around, kind of line things up. I'm also going to get out my protractor, and I'll show you once I'm all ready to go, have it set up for that. Alright, so I got my protractor out. I've got this lined up exactly with 90 degrees right here. If I draw a straight line going up here, this is going to match up perfectly with 90 degrees, which is what I want. I want to draw the perpendicular bisector. So I've already found the midpoint. It's already bisecting it. Now I want to make sure it's perpendicular. By doing this with your protractor, you will assure that that happens. So I'm going to draw a light line in here. With my light line, what I mean by that is that I'm going to use my smaller unit right there, and I'm going to continue this up, not forever, I just want to go up a little ways here. Basically far enough where if I go up and I go out from each direction this way and this way, that they're all going to match up. I may be erasing some of this stuff later on. So you'll notice here, if I extend this out 90, extend this out 90, they're all going to match up. So I'm going to pause it. I'm going to line it up with this side now, so you'll see me do that next. Okay, so now I've lined my protractor up with this side at 90 degrees. If I draw a line right here, I'm going to start at the midpoint and just keep going that way. Looks like it jumped on me a little bit there. Try that again. Still jumping on me. Oh, I tried to fix it, but it's still jumping. It's, for whatever reason, it's putting a little gap right there. But continue this out. This should be a lightly drawn but solid line right there. And so I'm going to take my protractor one more time. I'm going to spin it around here, line it up with 90 along this side. And right there. If you have done this right, all these lines should meet in the same spot. We call that the point of concurrency. So if all these lines are meeting in the same spot, you've done this right. If you don't have them meeting in the same spot, then you have not done this right. So this right here, if I continue that down to there, you'll notice mine isn't absolutely positively exactly precise, but that is pretty darn good right there. So where all these meet, I am going to take the rest of my lines and kind of back this up a little bit, keeping it straight. So you're erasing yours. I can't erase these solid segments that I make, so I gotta back mine up. So there we go. Now I back this up, and the way I had drawn this had to be the case. These had to be 90-degree angles. So I'm going to put little boxes in the corner. I actually measured them to make sure that they were 90-degree angles. So please do the same with yours. So you're doing all this in pencil, put the boxes in the corner right there. And the way we did this, we know that this is true as well. So let's add some things to the picture. We know that and that have to be the same. We know this and this have to be the same. We know this one and this one also have to be the same. Those are all congruent to each other. Here, here, and here. And step 4, our final step with this. So notice again, we're doing perpendicular bisectors of the triangle right here. So that's the first type of bisector that we're doing with this triangle. We are going to draw a circle centered at P, and I didn't label P up here yet, so let me do that right now. This is point P up here where they meet. I'm putting it offset just a little bit here because I need to draw something in here a little later. So centered at P with radius AP. So with radius AP. Done correctly, write this down still, done correctly, this is going to be true. Pretty cool that this works out. Done correctly, AP equals BP, and it also equals CP. And so what do I mean by that, or what do I have there? Let me get out my compass. So here we are, and I'll put this, you take out your compass, put that in the right spot, and this should be done lightly still. So drawing lightly your compass, as it says on your syllabus, you should have a compass at home. You're supposed to have that a long time ago. But let's open that up there, and this is, looks like my lighter version, so the triangle is a little thicker, a little darker. This is my lighter lines, drawing this lightly. Don't mess up on me here. So you'll notice mine is not absolutely perfect, but that is pretty darn good right there. They're supposed to touch right there. They're supposed to touch right there. It looks like I could have extended my compass out a little bit farther. Why don't I actually do that and make this look even better? So I'll say right at the very tip point right there. See if I can make it look even better. Keep skipping. Don't skip on me. Alright, that is, I'd say, even better right there. So the reason for this tiny little error is probably because this midpoint, one of these 3 midpoints was just a wee bit off. But if I draw in some extra lines here, now I'll take out a different color at this point. So pause the video if you need to, go grab a different color. We're going to draw these 3 segments in here. So AP, BP, and CP. We're going to show that in a different color, that these things are all congruent to each other. So connect A to P with a different color. Connect B to P with a different color, and connect C to P with a different color. Still skipping. Let's see if I can do this the other way without it skipping. There we go. And so what's going to be true, I'm going to use 4 marks here, because I've already used 1 here, I've already used 2 here, I've already used 3 here. So I'm going to put 4 marks on all of these. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. These all have to be the same. This is a special type of circle. This is called a circumscribed circle. So if you think of circumnavigating the globe, you're going around the globe. There's other words that start with that prefix, circum, that you can think of going around something. Let's see. And so let's draw some extra things in here. Let me get rid of my compass. Okay, so this is, I'm going to make mine a little thicker here again. This is theorem 5.5. This is the big thing to remember with this one. So what's true in here? This is true for this one, that PA I'll write it as AP since I did that down here that way. So this is true. AP equals BP, which equals CP. So this is the big thing to remember here. If you have a triangle and you make perpendicular bisectors coming off of each side, their point of concurrency, you make a circle centered at that, you're going to have this perfect circle that is circumscribed around the triangle. And so over here, let's label a couple things a little more. I'll do this a little more lightly. So this right here, this circle is circumscribed. Let's write that down. It's circumscribed. It's a circumscribed circle, just like Magellan circumnavigated the globe. We circumscribed the circle here. We went around the outside of the circle. So it's a circle about, that's just the language we use. It's a circle drawn about, drawn around, in other words, drawn about A, B, C, triangle A, B, C. So that's true of that. And then this point, point P, has a special name. It's easy to remember if you remember what type of circle this is. This is a circumscribed circle. This is called the circumcenter. It's a special type of center of a triangle, and since it goes with the circumscribed circle, I think they did a good job at naming it, calling it the circumcenter. Put a little period down there. And so now let's do an example dealing with this theorem. So we're also, with our examples, we're going to be drawing nice pictures too, nice neat pictures. So make sure you keep those tools handy. Alright, so with this one, I want you to start by drawing your best right triangle that looks like the triangle I'm going to draw up here. And so let's make this a little thicker, the actual triangle to start. And so make a right triangle, looks kind of like mine, as best you can, looks just like mine up here. So I'm going to make that the right angle. I'm going to make that 90 degrees, and that looks pretty good to me right there. Okay, connect that now. And so that's our triangle. I'll just verify that this was done well here. If I line that up, it's pretty darn close to 90 degrees right there. So that looks quite good to me. That looks like it'll work out just fine. And so from there, I'm going to ask this question. We're talking about sprinklers, or we've got a picture of sprinklers over here, and we're going to talk about sprinklers in this one. So a practical problem. What's the best spot for a sprinkler with plants? Let's say you have some plants at each one of these vertices. So there's some plants at each one of those vertices with plants at X, Y, and Z. So what's the best spot for that? This is going to be point Z over here. Put a little slash or dash through that so it doesn't look like a 2 to me. Let's put an X down here. This is going to be plant Y over here. Okay, so what we can do with this one, we can go back to this idea, what we just did here with theorem 5.5. We're going to find the perpendicular bisector of each side. So let's do that next. Before we get into that though, let's talk about why I'm actually doing that. So why would that be a good spot for the sprinkler? Well, kind of like in this one, if A, B, and C represented the plants, P, that point, would be the same distance away from each one of those plants. And so that's what I want to do with this problem too. I want to have that P in a central location so that it waters all the plants and it evenly distributes the water to those plants. So it's just touching all those plants without wasting water this way. So we're doing the same sort of thing here. I want to find what's the best spot, what's an equidistant spot for all of these. So I'm thinking that it's going to be kind of like maybe right about here. That seems like it's going to be equidistant between those 3 points. And so we'll notice something about this was an acute triangle, and we're going to have a right triangle here. We'll notice something about it as we draw our picture in this one. So let's start by getting out our ruler. We're going to find the midpoints of each side. So take out your ruler, find the midpoint here. This looks like it's about 80 to me. And so I would go midpoint right there would be 40. So that looks like right about there is the midpoint for that side. Do the same thing with the other two sides. I'm going to pause and just draw them in there to save us some time here. Okay, so over here I found this to be 92 millimeters. Halfway there was 46. I found this to be about 46 millimeters. Halfway there, it's about 23. So I connected, or I've got all the midpoints for those sides now. So let's go through our steps. Let's go back here. I've drawn the triangle. That was step one. I found the midpoints of each side. Now we're going to lightly draw the lines at 90 degrees through each midpoint. So now it's time to take out my protractor again. Close the ruler, get rid of that. And boom, that is. So let me rotate this around. I'll go with the bottom part first. A little bit more. There we go. Put that right there. And then draw my light line going up from there, drawing the perpendicular bisector right now. And I'm going to make that lighter, so I'm going to make my thickness a little smaller. You'll notice it looks like it goes right through that point right here. So I'm going to extend this out a little further. I may have to erase this. I'm doing this lightly. You're doing it lightly. So let's take this now, and line this up with the 90 degrees there. So that line, it's right at 90. I'm going to draw a line in right here. And so, gotta get my other one, there we go. So let's line it up right with the protractor edge. That's going to be good to go with that one. And I'm going to spin this around one more time. I want this to be lined up right with this. And I'm going to have my line coming right off that midpoint there to right here. So you'll notice something. The point of concurrency on this one, where they all meet, is right here, right on the triangle. Interesting. And so I'm going to take this one. I'm basically just going to get rid of this one because I don't really need that drawn in there. I'm going to take this one and bring it back a little bit right to that point. And take this one and bring it back a little bit. If I can grab it. Come on. Here we go. And bring it back right there. So the point of concurrency to me, my point P in a sense, is going to be right here. So let's label that with a P. So we're just going through these steps here again. Get rid of this at this point. So we call the point of concurrency P. You could call it whatever letter you really wanted to, but I just went with P again. And so let's call this one, where this meets, I'm going to call that A. I'm going to call this B down here. So what's my next step? We're going through these steps. Make sure as you're watching this should always be the case, but make sure that you're actually focusing on what I'm saying, and you're not just blindly copying this down or just mindlessly copying this down, would probably be a better way to say it. Don't be a mindless copier right now. Please, please, actually think about what's going on. If you study, in a sense, if you study right now, you understand it right now, this is going to be so much easier the rest of the time for this whole chapter. Can't emphasize that enough. When I was in high school, the time I studied the most, quote unquote, was when I was taking notes or when I was listening to the teacher explain things for the first time. If you do that well the first time, it just makes things so much easier the next time around when you think about it. So all of these things, I think I do want to draw in a light one here. So let me go back to this, and I'm going to draw in a light perpendicular bisector here, just so we know that there was something actually there. Okay, so notice that I drew this in here. That's at 90 degrees. This is at 90 degrees. This is at 90 degrees. So let's label those things lightly in the picture. So right here, that's at 90. Right here, this is at 90. Right here, this is at 90. And this is also true. We've got that this side is congruent to this side, or that segment to that segment. This is still P, so I'm going to put a P right there. I've got this segment congruent to this segment. I already measured that. I saw that was halfway. And I have this one is congruent to this one. And so what's my last step here? Back my steps back here. This up. And the point of concurrency, we have that. So we're going to draw a circle just to verify that this is actually true. So Let's see what we got here. Let's get out our compass and we'll center it at P. And I want it to just, not ready for that. Close that up a little bit. It sure is skipping a lot today. I have not had a good day with my my program here, Active Inspire. Okay, so I want to take this, rotate it a little bit more. There we go. So that it just touches the edge there. Now if I drew this right, it should just touch on all the spots. Should be real close. Okay, that's looking pretty nice there. So if I go back here, you'll notice I'm not going to draw in the whole circle this time. We don't really need the whole circle. So we just have the portion of the circle that we really need here in question. Take out your different color now. Let's get out that different color and let's draw in. I'm going to use orange for mine. Draw in the segments here. And I'm going to draw in a segment here. So draw this in a different color, basically right on top of what you drew there. And you're going to draw this in a different color right on top of what you drew there. So you got a different color here, here, and here. All of these are also the same. So this one, I don't need to redraw this. This mark is already good to go for that one and that one. If this mark and this mark are the same, this one also has to be the same. So I'm going to put one mark here. I've got one mark here. And I've got that same mark here. So I don't need to redraw that. I'm going to get rid of that one. So one mark matching up with one mark here. These plants are all, now if we put the sprinkler right there, they're all the same distance away. These perpendicular bisectors meet right here at this point of concurrency, and they're all the same distance away from each one of the plants. So the sprinkler will water each one of the plants this way, as long as the radius here is big enough. There was one other thing I wanted to say with this one. So let's assume that this was, I'm going to use black for that. Let's assume that this was 5 feet from P to Z. So this point P right here, that is our answer. The best spot, I'll put SOLN for solution. I would say point P is the best because it is the circumcenter. It's going to be the same distance away from all those points. It's the circumcenter. And so what kind of sprinkler do we need to buy? I've gone to Lowe's before. I bought some sprinklers and I had to make sure I had enough of a watering radius it could actually reach the grass or the plants I was trying to water. So let's make one more little note here. As long as the sprinkler has a, what's the watering radius got to be for this one? Well, I think you're going to be okay with this, but 5 feet. I think any sprinkler of any worth should be able to at least reach 5 feet out. So from here to here, it's going to be 5 feet, but the same thing is going to be true from here, P to Y and from P to X, the way we've drawn this. So as long as the sprinkler has a watering radius of 5 feet, the water will reach each plant. Okay, so I need to see this neatly drawn in your notes. If you want full credit for the notes, you have to have used those tools. I can tell if you use the tool or not. Alright, so let's make a note right here. These pictures, don't draw these pictures down unless you really, really want to. These pictures can be found also on page 272. So if you want to write that, if you do choose to write this stuff down, and or you just want to refer back to it later, these can be found on page 272. This note that I'm going to write here, this goes with, I want you to write this off to the side too, this goes with theorem 5.5. And we noticed something, or hopefully we noticed something here. This was an acute triangle. The circumcenter ended up being inside the triangle. This is a right triangle. Right angle right here. The circumcenter ended up being right here on the triangle when it was a right triangle. If we extended this to obtuse triangles, then it would be outside of the triangle. So you'll notice my triangle looks pretty similar to this one, and my other triangle looked pretty similar to this one. And then if I drew an obtuse triangle, the circumcenter would end up being out here. These are all perpendicular bisectors. So this angle is 90, this angle is 90 right here, this angle is 90 right here, and it's cutting it in half, splitting it in half. They meet right there. So for acute triangles, important note to make here, acute triangles, the circumcenter is inside the triangle. For right triangles, that's right here, right triangles, circumcenter is on the triangle. And for obtuse triangles, excuse me, circumcenter is outside the triangle. This is always going to hold true with these types of triangles and with perpendicular bisectors. So remember, all we're doing right now is perpendicular bisectors. So if you want to draw these pictures, you can. If you just want to look at them later, you can look on page 272 as well. Let's do the other type. So we've done perpendicular bisectors to start. Perpendicular bisectors goes with a circumcenter. Now we're going to draw one with angle bisectors. So this one, please make yours look similar to what I have up here. Make your triangle look as close as possible to what I have here. So this one, let's go with a triangle. It looks, I actually want to make that a little bigger, or a little thicker, I should say. So let's go, try that again, there we go. So I want the actual triangle part to be a little bit thicker. So draw this in, nice and thick. This one, we're going to make this, try to make it acute as best you can. This one's going to be this angle pretty close to 90, but just a little bit less. So I'm going to go with something like that right there. And I'm trying not to make it isosceles, just so you can see that this works with any triangle, any old triangle. It doesn't have to be a special type of triangle. But this one is acute, just barely. This is a little bit less than 90. I can tell right there. And so let's draw in or write in some of our steps. Let's write those down here. So step one, we don't have to leave too much space down here for this one. You don't need as much for what we got here. Step one is to draw any triangle you want again. So draw any triangle you want. And we'll call it, we'll keep it simple, we'll call it triangle A, B, C again. So I'm going to put an A right here, I'm going to put a B right here, and a C up here. Do the same thing on your notes here. So step two. Same sort of thing as before, but instead of now lightly drawing the perpendicular bisectors, we're going to lightly draw angle bisectors. And let's see what happens when we do that. So to find the angle bisectors, I need to find how big this angle is. So this I need to measure precisely. I need to take out my protractor, and I need to line this up precisely. And so I'll notice that this, I do notice that this is, if I put it right, it looks like it's pretty good right there. I'm saying that's about 42. So if I cut that in half, I'm going to have a point right here at about 21. So let me do that. It's not letting me draw that. There we go. I got a point right there, right at about 21. If I extend this out here, 21 degrees. So I'm going to move this and lightly draw that in, drawing in a line, and using my pencil at this point. or you're using your pencil. Let's make this a lighter line, so I'm going to use the lower thickness here, connecting A to what I just did right there. Make that a little bit closer in the edge. There we go. Of the vertex. Now that doesn't look right to me. Something looks a little bit off. So let me check something there. There's my problem. So I went with, I said 26 here. It's 42. Half of 42 is 21. Silly, Mr. Wagner. There we go. That's where it should be. So let's fix that up now. So sometimes I'm human. I make mistakes, but I fix those mistakes. If I make a mistake, I make sure that I undo that and get rid of that. Alright, so angle bisectors, they should look like the angle got split in half. That's how I noticed that mine was not drawn correctly. It didn't look like it split it in half. So now if I do that, that looks much better. That angle looks the same to me as that angle. So I'm going to do the same thing with angle B. I'm going to do the same thing with angle C. We can extend this out farther if we want, and then we can erase when we're ready to. So let me measure this angle. So this one looks like, if I'm going from 0, I'm going to about 53, 54, right in that range right there. Maybe that's 52 right there, so it's 53, 54. So half of that is going to be in between 26 and 27, a little bit closer to 27. So I would say that's right about there to me. If I extend this out, here's 26, 27, right about there where I want that. Move this out of the way now, and let's get a ruler. We'll draw a straight line here, and connecting B to that point I just made. A little bit closer. No, not quite. Right there in the corner of the vertex. That's pretty good. Okay. So connecting those. This I'm going to be erasing a little bit, backing up a little bit, and then see if I do this right, or if I did this right. This, when I connect it, it should touch right there. It should have a point of concurrency again. So let's see if I actually did those first two right. If not, they will not match up in the right way. Let's see what we got here. So this is going from 0 to, it looks like 85 degrees. So half of that is going to be about 42 and a half. So we take this right about here, I'd say. And let's make now a line connecting those points. So from here to there. And do they match up? Do they go on the same point? Do they have that same point of concurrency? They sure do. So this looks really nice to me. So I'm going to take all these and just kind of back them up to where they meet, so you can erase yours. If you didn't get them to match up, try to figure out why that happened. So remeasure your angles. You may need to adjust the angles just a little bit. So this is going to back up to where they are meeting right there. Oh, I grabbed the wrong spot there, I think. Won't let me do that. That's not what I want either. Just a second. Alright, so we got it good to go now. I'm just going to erase these little marks over here. I don't need those anymore. Okay, so my point of concurrency, this we are going to label as before. We're going to label point of concurrency, or call the point of concurrency P. So let's give this a label up here. We'll call that P. That's where they meet. And from there, just one more step with this one. Step 3. We're going to do this. Draw a circle centered at P that just touches all the sides of the triangle. So let's see if that actually works here. So this centered at P, I'm drawing a circle around there that's supposed to just touch right here, and right here. And this we will draw lightly. Take out your compass. Got my compass here. Center it at P. Rotate it as necessary. Close mine in a little bit. And I want it to just touch the sides this time. So just touch down here. So I'm going to rotate mine down. You'll notice if I drew it right there, it would overlap just a tiny bit. So I want to pull this in just a little bit. And let's see if I've got it now. Is it just going to touch the side right there? If I draw it, it looks like it'll just touch the side right there, and it'll just touch the side right there. So I think I'm ready to draw. I think I'm good to go here. So let's draw in the circle. Ooh, that is pretty. And hopefully yours looks as pretty as that does. So we're going to take, at this point, we're going to draw in. We're going to make a little point each spot where they actually touch. So I would say it touches right there, it touches right there, and it touches right about there. And connect P to each one of those points. We're going to label this point E. This is actually called the point of tangency. You'll learn more about that later, but the point where the circle is tangent to the segment there. So that's D, E, and F. Let's connect those. And at this point, we're using a different color. So get out a different color. I'm going to get out my orange. You can use what color, whatever color you're using. Connect P to F. You'll notice this is not necessarily a straight line. This is, in this case, it looks like it's pretty close to being straight, but you'll notice this one, A to D, this is not a straight line here. B to E, not a straight line here, but this is true. This one, and this one are all the same. We forgot to label something else here too. I forgot to label something else. I meant to draw in that this was true. The angle bisectors, that means these angles are congruent. That means up here these angles are congruent. I'll put 3 here since that was C. It's not really something I have to do C with 3 and B with 2, but I could do 2 up here and 3 down here instead. But this is matching up here, this is matching up here, this is matching up here. And now this is the big thing. This right here, we learned this in the last lesson, the prior lesson. This is the distance from P to the side. The distance from P to the side, it's the perpendicular distance. This is the shortest way, the quickest way to get from P to this side, the quickest way to get from P to this side, and the same thing here, the quickest way to get from P to this side of the triangle. So let's finish up our thought here. Done correctly. PD equals PE, which equals PF. This up here is theorem. This is big, this is important, so I'm drawing this in a little thicker. This is theorem 5.6. This is PD equals PE equals PF. And so that point right there has a special name, and it's analogous to what we had over here. You had a circumscribed circle, it's called the circumcenter. Over here, what we just did, we have an inscribed circle. It's on the inside. Instead of circumnavigating around the outside, it's on the inside, just touching all the sides there. This is called the in-center. And this circle right here is an inscribed circle. Inscribed, inside, in-center, they kind of all go together. So inscribed circle within, instead of about is kind of going around, within is inside, so within triangle ABC. And with in-centers, a little extra note to make here. This is true. It's always inside the triangle. It doesn't matter if you're doing angle bisectors. It doesn't matter if you have an acute, obtuse, or right triangle. The incenter always ends up being on the inside. Unlike we had here with the circumcenter. Sometimes the circumcenter, depending on what kind of triangle it was in different places. That's not the case with angle bisectors. If you draw in any angle bisectors, they're always going to meet inside the triangle somewhere. Okay, so we're going to do one final example here. Example 2. I want your triangle to look like mine as best as possible. And I want you to draw a right triangle here for me. So let's make this a little thicker. Let's make one side here. And I want you to actually get out your protractor and measure this, because I want to make sure that it is a right angle right here. So this right here, I'm going to rotate it around until it hits 90, and that looks good. Oh, looked good. Okay, that looks good to me right there, and I'm going to start drawing in the other side based on that. Okay, so if I line it up with 0, I'm going to pull this back a little bit in a second, but that looks good to me right there. Let me just adjust that just a smidge. Okay. Move this out of the way. And so I've got my right triangle right here, and I'm going to draw in my final line here connecting these. I'm going to make mine go straight across. And let me just fix this up a second. Alright, so that looks like a pretty nice triangle right there. And I'm going to, from here, I'm going to try to draw the in-center and see what happens with some of these things. So take out your tools, keep those tools out, and we're going to find the angle bisector of each angle right here. Your angles may be a little bit different than mine. This one, though, should be the same. This one was 90 on mine. It should be 90 on yours. What's half of 90? That's 45. So I should have a degree measure of 45 right out here. And I'm going to draw in a light line connecting right here. A light line from here to there. So I'll bring this back. I'll erase some of that later. We're doing this lightly so we can do that easily. And now let's measure each one of these other angles. So line this up here right with the center point here. Okay, that's lined up with 0 now. Let's see what we got. It looks like about 60, just a hair under 60. So I'm going to have about 30, just a skosh under 30, right about there. Looks pretty good to me. And so let's draw in a line from there. Here, connecting to here. We got it there. And do the same thing over here. Same sort of thing. This looks like about 32 to me, so let's draw in a point at 16 then. That's halfway of 32, or half of 32. And if I did this right, if I connect these should all match up. And let's see if that in fact is the case. So drawing this from here, did it again. I'm feeling it's going to do the same thing again. Nope, it made it. Okay. So does that go where I wanted it to? Looks like it's perfect, right on the money. So this right here is the in-center. We have these angle bisectors drawn in here. Let's draw those things in here now. This is 1 and 1 we could put here and here. Could put 2 and 2 here and here. I could do 3 and 3 up here. So those are all looking good. I'm going to bring this back. You're going to erase yours. Okay, there's that, and this one here. Okay, so I brought that one back. I'm just going to erase my little markings here, and I actually wanted to bring that one back a little bit farther. Just a second. Okay, so that is good to go now. Brought that back a little bit farther. That point right there, this time I'm going to give it a different label. I'm going to call it L. I could call it P. That would be consistent with what I have done, but just to make a point here that it doesn't always have to be called P, I'm going to call it L. I'm going to say this is A, B, and C. We'll stick with that for our vertices of the triangle. And then I need to still draw in those distances. So straight to the sides. Got to make sure it's 90 degrees. So let's move this over here. Spin this around. I want to line it up exactly with that and exactly with 90. Got to move this up just a little bit more. So you're using your protractor for this. It's not lined up with 90 yet on mine. It's pretty close. Now it's lined up with 90. I just need to move this that way just a little bit more. Okay, so that now looks good to go. I'm going to draw with my line tool here. Use a ruler for this, or use the edge of your protractor for this. And let's draw that in from here to there. Okay, and doing the same thing over here. We need to make sure it is actually 90. And draw that in there to the edge. Extend this out just a little ways. Okay, and then draw this in precisely at 90. Just need to make sure it lines up with that. Okay, so lined up there. And let's draw that down. Let's make that just a little bit better. There we go. Draw it down there. So it looks like we're all good to go from there. What's going to be true about this? Well, I could get out my compass, so let's get out my compass right now. I'll do this lightly too, just to verify that this is correct. We'll move this point right to the point of concurrency right there. Bring this in a bit. Rotate it around. It should just touch right there. So I kind of did this the other way this time. I drew in the 90-degree marks. I could have drawn my circle first and then connected the point of tangency. So we can see that either way kind of gets us the same thing. Let's use black for that again. No. Didn't I pick black? What the heck? Okay, I don't know what's going on. Just a second. Well, when life gives you lemons, make lemonade. So I'm going to just take this and grab it, take my property browser, and don't know why it won't draw in black. Just change it to black. There we go. And that's good now. So this just touches right there. Mine wasn't exactly perfectly superbly done, but you can see that that point right there is pretty darn close. If you're at least that accurate, you won't have any problems. I will say you're good. So that point right there, that point right there, and this point right here, let's give those points all labels. Let's call this F. Let's call this up here D, and we'll call this one E. So I want you to label this for me. So we knew this had to be true. We knew these were 90-degree angles. And those three spots. And then I want you to take your pencil and lightly shade this in. I'm going to use a gray here instead. Okay, so the gray will be representing my lightly colored in pencil part here. So we're going to be looking at this particular triangle specifically. So fill that all in. Just do this lightly with yours. and we're going to say that, I'm going to go back to black here. We're going to say that this was 6. Down here, DL is 6, and this is 8. This is not drawn perfectly to scale, but we'll suppose that it is. So this is 6, this is 8. We know that this would have to be a right triangle as well, so I'm going to draw that in, a right angle right here. Let's draw that in. And do you see the right triangle? I see a right triangle right here. This is going to be 6 and 8 and this side. So I have 6 squared plus 8 squared equals whatever this is squared. Our goal, our objective here, I haven't told you where we're going with this yet. Shame on me. Our goal here is to do this, to find AL and FL. You're going to have one like this on a quiz and on a test. You're going to have to be able to do something like this. So we drew this in. First of all, we drew that carefully. And I can see that based on the picture, FL is really easy to figure out. So this is 6, and this is the same based on theorem 5.6. So I can tell you right away that FL equals 6. Why is that true? You look at theorem 5.6, it says it's true. So PD, PE, PF, all the same here. If you can draw that inscribed circle with angle bisectors, which is exactly what we've done here. We had angle bisectors and made our inscribed circle. That had to be the same. So to give a reason, put this next to that theorem. 5.6 is my reason for that. Now, what would this other one be right here for AL? Let's call it X just to make it easier in the picture. So AL will represent with an X. We should remember our Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. So let's plug in our numbers here. I've got a 6, I've got an 8 for my legs. The legs make up the right angle. The hypotenuse is across from the right angle. It's the longest side. So this is equal to, we're calling it X. Could you call this AL squared instead? That would be totally fine. So this is 36, this is 64, and this is X squared. Add these together, got 100 equals X squared. From there, take the square root of both sides. I'll use my different color here just so you notice that it was kind of 2 steps in one, and this becomes now 10 equals X. X represents AL, so I'll put on the other side that this was the same thing as AL. Did I give you units on this one? Nope, no units, so you don't need to include units on this. So that was the last example we'll do together. We will definitely be practicing drawing some of these more in class just to see that you're getting the hang of it. But you have to have nice drawings here with examples 1 and 2 and with your theorems themselves. So I should see four really nice drawings to go along with this lesson. And let me know if you have any questions in class about this. Thanks.